Let's look inside batch sampler for a bit. Now, as before, we'll create our data set, this time with 10 rows in it. And we'll create our data loader, pass it the data set, but this time we'll specify the batch size as 3. And then we'll just iterate through this data loader. I think I had a cell up above. Yeah, there it is. Let's just convert this into a function. Now we call this function and let's see what we get. And as expected, we see batches of size 3. And the last one has just one data element in it because 10 is not divisible by 3. And we can change that behavior if we want. So let's pass in another flag called drop last equals true. And so it just dropped the last batch because it was not a full batch. Let's now examine the data loader that we've created. We had those print statements that we wrote earlier. Let's convert those into a function. And upon calling this function, we see that it has the same sequential sampler from before. We have the batch sampler. The only thing different is that the batch size is set to 3. And we can even look at the drop last attribute of our batch sampler and verify that that is indeed set true. We can create the batch sampler ourselves. So let's try doing that. And we can see that the first parameter is a sampler. So let's give it a sequential sampler. The second parameter is the batch size. So let's specify that. And finally, the last parameter is drop last, and we'll set it to true. Now, this is just an iterator. So let's iterate through all the indices in each batch and see what we get. And these are the indices of each batch. So the first batch will have data from indices 0, 1, and 2, and then the next one will be 3, 4, and 5. Now let's create a data loader using this batch sampler. So we just copy the cell above and then instantiate a data loader. Apart from passing in the data set, the only other argument that we need to give is the batch sampler. So there's no need for the batch size or the drop last or anything like that. And now let's iterate through this data loader and we'll see that we get exactly the same results as before. Let's see the way we had created the data loader earlier side by side with this way of creating it. So these two statements here and the 3 statements up above, they are completely equivalent. We can disable the automatic batching behavior of the data loader by setting the batch size argument to none. Iterating through this data loader shows us that we get the rows as is from the data set. There has been no collation happening of converting them into multidimensional tensors or whatnot, or the only thing that the collation function did was convert the NumPy array into a tensor. And upon examining this data loader, we see that the batch sampler is none, and we get this attribute error because we were trying to examine the attributes of a none object. And while I'm at it, let me go fix this function to handle the none case. So far, we've been using the default batch sampler, but we can also write our own. So we can, let's write a crazy batch sampler that will give us the elements in reverse order, and it will increase the batch size by 1 with every new batch. So the first batch will just have 1 element, and that is the data at index 9. The second one will have 2 elements from indices 8 and 7. Third will have 3 elements from indices 6, 5, and 3, and so on. Let's call our class revlin batcher for reverse linear batcher. It needs to derive from the sampler, and we'll take in a data source so we can get its length. And then we implement the iter method. This is the only method that we need to implement. And here we'll start with a size of 1 and an empty batch. And then we'll iterate through the indices in reverse order, adding each index to the batch and then checking if the batch is of whatever size it needs to be. If it is, we yield the batch, reset everything. So set the batch to an empty array, increase the size of the next batch by 1 more. And finally, when we come out of the loop and we still have some elements left in the batch array, we yield that. Now let's check if our custom batcher actually works. And it pretty much does what we wanted it to do. Now let's create a data loader with this custom batch sampler. And like before, the only other argument apart from the data set that we need to give to the data loader is this batch sampler and nothing else. Iterating through this data loader, we see that it does pretty much what we expect it to do. Just the last batch is a leftover batch. Let's see if we can get rid of it using the drop last flag and setting it to true. Okay, it seems not. We get a value error, and as the error message tells us, we cannot use the batch sampler argument with the drop last flag. Why do you think that is? Pause the video here and think about it for a second before you move on. The reason is that when we specify the batch sampler, we are telling data loader that, hey, don't use the default batch sampler, use the one that I just gave you. But when we are setting the drop last flag, we are telling the data loader, hey, when you create the default batch sampler, pass this flag down to it. So really we're telling the data loader to create two different batch samplers, which does not make any sense, and that's why it gives us an error.